Hello, I'm Jason Holmes, a meteorologist here with the Weather Service in Birmingham. Going to just go through a quick review of looking at winter weather forecast soundings and relating what you see in the profiles to the expected types of winter precipitation. What has traditionally been done is looking at critical thickness charts, looking at either the 1,000 to 500 millibar layer or the 1,000 to 850 millibar layer. And even today, these charts are still useful in determining, just at a cursory glance, what areas may experience some winter precipitation. But what we found is, this information varies greatly, and it all depends on the lower levels of the atmosphere, what the thermal profile looks like, and those important features just are not representative in these layer average charts. It's just not going to be able to depict that very well. So looking at a vertical sounding profile is a must to get a much better idea on the precipitation type and ultimately the impacts that an area could experience from winter weather. Um, and as y'all know, it all comes down to these layers, the warm layers, the cold layers, and how thick they are and where they're located. Of course, for a cold rain, you just need a warm layer aloft that melts the snow as it reaches the surface. It stays rain the whole time once it melts. When that warmer air is a little bit further off the surface, you get an Arctic front or other kind of shallow cold air mass near the surface. You still get the snowflakes melting to rain, but then it refreezes near the surface and causes freezing rain. When that warmer air layer is even shallower, you still get the snowflakes to melt to rain, but it quickly refreezes back to sleet once it goes into a freezing layer that's deep enough and falls to the ground as sleet. And of course, if you don't have much of a warm layer or none at all, the snow from aloft will make it all the way down to the surface. So it's all about being able to profile what the atmosphere is expected to look like temperature wise once you determine that there's enough moisture to support precipitation. And thankfully, these days there's so many resources on the internet. I just listed a few here. There's probably a lot more that you use and others that use as well. Pivotal Weather, Twister Data, and also College of DuPage. Just a few websites that have this opportunity, the ability there to where you can actually pull up forecast soundings. But we use generally a 5-step top-down precipitation method. The first step, we need to make sure there's moisture there. We need to see the moisture in the snow growth region. Snow growth region generally between -10 and -20 Celsius. For maximum snow growth, that would be -12 to -18 degrees Celsius. You're going to be looking at a fairly moist profile, so dew point depressions no greater than 5. That's really the best environment. And if you look at surface to 500 millibar relative humidities, I mean, that should be pretty high as well in that layer. So once you determine there's enough moisture, look at the warm layers in the profile. If it's 0 to 1 plus degrees Celsius, a little bit above freezing, you're not going to have much melting. But once you get above 1 Celsius to 3 Celsius, you're going to get at least partial melting. Generally, the snowflakes lose their identity and become water with an ice core in it. And then once you get above 3 Celsius, generally you'll have complete melting. So as we continue on, if you've identified any warm layers, we'll look at any kind of sub-freezing layers. Obviously, if there's no warm layers, you won't have any sub-freezing layers. The whole profile will pretty much be below freezing at that point. But looking at the sub-freezing layers, will the sub-freezing depth be great enough to cause the droplets to refreeze, regain that ice nucleus or not? That's a question for that step. And then look at any kind of dry layers, because as you know, evaporational cooling, surface temperature and low-level temperatures may be above freezing, but if you have dew point depressions that are great enough, as that moisture falls down to that layer, generally falls as virga, doesn't reach the surface, that evaporational cooling will bring down those temperatures, and then have to watch that very closely. Generally, if you have dew point depressions greater than 20 Celsius, that can cause some significant evaporation or sublimation. If it's 10 Celsius or below, it should not be significant, is what we found. And then look at your surface temperature. Obviously, that's the big thing for the surface conditions. Obviously, if it's freezing aloft, and then you have a warm layer, then you have freezing near the surface, freezing temperatures, you can get, freezing rain. If it stays cold through the profile, snow, and if it's warm through the profile, rain. So we're going to look at now some classic winter weather soundings. These are observed soundings, not forecast soundings. So they just kind of give you the classic things, to look for. This is your classic cold rain sounding here on the SCUT. And what I've done here is I've emboldened the freezing line here, the 0 Celsius freezing level here through the SCUT plot. And here's your temperature in red, your wet bulb temperatures in the light blue, and then you have your dew point in green. Obviously, from this profile, as you can see, it's very saturated here. Once you get below about 650 millibars, but the whole point here is that the temperature goes above freezing about 700 millibars, and it stays above freezing the whole time. Cold rain sounding, plenty of moisture here, but it's all above freezing. So cold rain with that one. Here's your freezing rain sounding. You can see the similarities from a regular rain sounding, but the difference here is near the surface. See here about 900 millibars. Your temperature goes below freezing and stays below, below freezing as you go down to the surface. It's just about right at freezing there. Saturated through this profile. There's no concerns there about it being too dry. This is a signature of a classic freezing rain sounding. It's warm aloft, and then you get the layer just above the surface there being below freezing. Sleet, ice pellets, it's similar to the freezing rain sounding to some extent. There's a little bit more drier air here in the lower levels. You can see where your wet bulb temperature is. It would drop a few degrees there if that moistened up all the way, but very similar characteristic. You do have a warm layer here, but it's not as significantly deep as the freezing rain sounding. And then of course the profile goes back below freezing and stays below freezing for a longer duration above the surface. Again though, fairly moist conditions, and this is a good profile example of that. And finally, your snow sounding, is fairly straightforward. Here's your freezing line. The whole sounding remains below freezing, so there's your snow profile. We're going to look at a real world scenario now. Obviously, things become more messy in the real world, particularly when you're looking at these models, which don't have the best vertical resolution, particularly near the surface. But this is from the GFS forecast model on January 29th. I'm using data from a internet website. Here's just a look, just the 4 panels here, looking at a loft down towards the surface, and our interest area here is southwest coastal Canada. You see there's a vorticity coming in, and there's good divergence aloft, and there's moisture at 700, and pretty cold temperatures as well. Looking at the forecast sounding area, looking at 3-hour QPF, here's some decent QPF expected here. In anywhere from half of an inch to an inch of precip. So I've numbered these boxes where we take forecast soundings. Number 1 near the coast. And what you would expect, it looks like we'll have rain here, 48 degrees there at the surface. Your freezing level, just close to about 740 millibars or so. So the profile becomes, warm and stays warm here once you get down below that area. Our second area is going to be a little bit further to the north. We'll take a look at that one. This is more of a freezing rain kind of sounding. Again, very good moisture here in the snow growth region. And down here, the profile, the temperature does warm, so this does melt a bit. And but then the temperature profile becomes below freezing again as you get down to the surface, about a surface temperature of 30 degrees. So, there's some melting that happens, and then as the precipitation gets down to the surface, it refreezes again. So this is a freezing rain sounding. We're just going to go back again, part 3, a little bit further inland, and there's some elevation here as well. So number 3 is, it's close to a sleet sounding. I think a sleet sounding, you would have a little bit more pronounced warm layer there, but you see the characteristics is similar to what you've been looking at. Plenty of moisture here in the snow growth region. You do have a little bit of an area here where it goes above freezing, but not nearly to the extent of a freezing rain sounding. And then, of course, you have a little bit of a deeper freezing layer towards the surface. So as it gets down to the surface, it refreezes again. And then our other site, a little bit further inland, it's all snow here. As you can see, the whole profile stays below freezing. It's moisture in the snow growth region, no dry layers, and no warm layers as well. So perfect example of that. So obviously the challenging situation, freezing rain versus sleet, it's all going to come down to the depth of that cold layer near the surface. The shallower it is, the more favorable that will be for freezing rain. If you have a deeper cold layer near the surface, sleet may be more probable. And also you're looking at the depth of that freezing layer, that warm layer aloft. If that warm layer is deeper aloft, it's going to allow for more complete melting um, compared to it being shallower. So more complete melting, you could get a higher chance of getting freezing rain. But if you have less melting aloft, a shallower layer, you have a better chance of having that ice core remain intact and it just become refreeze as sleet. So those are definitely more challenging to imagine. But this is another graphic generated by the Weather Service in Mobile, just showing you the difference here between sleet and freezing layer. Rain, it's all about that deep warm layer, and you see there the difference in the size depictions on that graphic. And this is another one from the Weather Service in northern Indiana. Again, just showing you that it's all about the size of that warm layer and the size of the cold layer there as you get towards the surface. So I hope that helps with winter weather. Always interesting here in the southeast. I want to thank all these sources that we were able to consult here for putting this together, and hope you enjoyed this.